Thanks, Dr. Sarah, for your invitation and this kind of opportunity. This is the third time with you.
It's our pleasure.
Yes, thanks a lot. We are talking about implant-assisted overdenture. The last lecture, we talked about tooth supported overdenture. So we continue this series of overdenture. First, we are talking about the classification of implant-assisted overdenture. It is classified to complete implant-supported fixed prosthesis and implant-assisted removable overdenture. So we have a fixed type and we have a removable type. Some authors may increase another or modify this classification by add another type, what we call hybrid type or the fixed removable type. First, we will talk about the complete implant supported fixed prosthesis. It will be divided into full arch veneered bridge, PFM bridge. The second type is hybrid prosthesis or fixed removable prosthesis. Then we will talk about implant assisted overdenture, removable overdenture. It divided to implant supported overdenture and implant retained overdenture. Here, as we see in the photos, here's a fixed crown and the bridge supported by dental implant. Here, it will be cemented to the abutment of the implants. The second type of hybrid prosthesis or what we call screw retained implant supported dentures, as in all on X types, all on 4 or all on 5 or all on 6 types. We will here use an angulated implants as all in 4 concept to avoid the injury of inferior alveolar here or the maxillary sinus in the maxillary arch. And we use multi-unit abutments as you see here in order to make the prosthetic platform parallel to the bus of insertion of the prosthesis. So we connect the abutment to the implant as you see here, and then using another screw to connect the prosthesis to the multi-unit abutment. Here, the first type of implant-assisted removable overdenture, what we call implant-supported overdenture. The total support of the prosthesis will be gained by using the bars, as we see here, or telescopes. And this is the last type of overdenture, is implant retained overdenture. This is only we can gain retention from the implant, and support and stability will be gained from the alveolar ridge. First, we will talk about the advantages of overdenture. It increases the bone density when implant inserted and loaded. So it will maintain the bone around the implant, not as the tooth supported overdenture. The periodontal ligaments of the abutment teeth will make the bone continuously under tension. This tension will lead to maintaining the bone. Here, the implant also have the same rule as the periodontal ligaments, but less. We have some bone resorption around the implant. Even it makes you make it perfect, but you also may have some bone resorption around it. Maintenance of bone volume when implant is inserted is also recorded. Setting of artificial teeth with more statics and phonatics. Allow use of cantilever. You can use of cantilever posterior or anterior to avoid the ridge loading. You can have a very stable jaw relation registration in comparison with a complete denture prosthesis. Then we want to know about the requirements of implant-supported overdenture. To make an implant-supported overdenture, you need mandibular at least 4 implants. Maxillary, you need at least 5 or 6 implants. Bar or support, bar. Here we use most commonly the bar attachment, or we are using sometimes telescopic attachment also. Here we gain all of our support and stability. We gaining it from this bar, as you see here. The prosthesis is totally supported over this bar, and the ridge will not share any type of load with the implant. Here, the bar is the male portion, and the female portion is a clasp added to the fitting surface of the denture, and will be used this clasp will be used for gaining the retention. Here, the impression needed for these types of dentures or overdentures is minimal pressure impression technique. The advantage of this type is optimal oral hygiene maintenance, optimal aesthetics, decrease the bulk of all prostheses. This will increase the accommodation of the patient to the prostheses. This is gained by decrease the flange length and the open palate form you can give to your patient. We don't need here the physical means of retention, so we will gain all our retention by mechanical interlocking with the implant abutments. Minimal soft tissue coverage. This will be very beneficial in increase thermal stimulation, increase taste sensation, and decrease the gagging. This is also, we can gain the neurointegration. This will be a compensation for the proprioception of the periodontal ligaments. So the patient can control his biting force and have a more chewing efficiency more than the patient wearing the complete denture. Then we will talk about the implant retained overdenture. Retention here is only gained by implants, and the most of support and stability is gained by the alveolar ridge. As you see here, we use a few number of implants, 2 or maybe 3. We can use 4 also, but the type of attachment here is resilient, so it's considered as an implant retained overdenture. Attachment may be used here, ball and socket type, telescopic, bar, or magnets, maybe locator and equators also. Adequate 3D orientation of the implant is essential to ensure proper vertical and horizontal space required for the placement. Okay, we will talk about the advantage of implant-supported overdenture. The advantage is good facial support in residual ridge resorption cases, the cases that the patient may have advanced residual ridge resorption or flat ridge cases. This is very beneficial to use this type to gain all the support. We have an abused ridge form here, not indicated for a proper support. So we will use the implant to gain the full support here by making a bar attachment and use it to have the full support of the prosthesis. Less implant number, so it will be less expensive. This is very beneficial for your patient if he can't afford to make a fixed restoration above the implant, so you can use a less number of implants, and this will give a cheap option for your patient if he can't afford the fees of the total fixed prosthesis on implant. It can be removed easily, so the patient can do his oral hygiene measures perfectly, and this will maintain the long lifetime of your implants, and also maintain or prolong the time of the prosthesis in the patient mouth. Good occlusal stability is also can be achieved or could be achieved in this type of restorations. Support from the buccal plate of bone, stability from lingual flange, and last, improve masticatory function and nutritional balance. Disadvantages here: poor support and stability from implant. Here we talk about implant retained overdenture. we can't gain a lot of support and stability of the implant. We can only gain retention, bone loss of the alveolar ridge posteriorly, because we share between the alveolar ridge and the implant. The type, the area of the alveolar ridge that's subjected to the forces will have bone resorption, and this will need for future relining. The design here, 2 implants at least with a splinted bar, or and retention will be gained by claps or sleeves, or non-splinted 2 implants. Non-splinted means not connected to each others. We can use with them the ball attachment, locator, equators, or magnets. This is a solitary attachment, not splinted. Here, the factors affecting the amount of ridge support is arch form and size, ridge parallelism to the occlusal plane, palatal vault shape, and the vestibular depth is also affect the number of implants that we can be used and the amount of ridge support we can gain. Then we will talk about the attachment that will be used for overdenture. As we see, as we said in the last lecture, an attachment is defined as a mechanical device used for retention and stabilization of the prosthesis. The attachment is divided to splinting and non-splinting attachments. The splinting attachments, as we said before, bar attachment, and the non-splinting attachments as ball, telescopic, magnet, locator, equator, and resilient denture liners also can be used as a female housing for the bar. It can also be divided into rigid attachment and resilient attachment. The rigid attachment don't allow movement of the denture base, and this provide adequate, very adequate retention. And this type of rigid attachment also can give us good support and stability for the denture. However, it induces more torque on the implants. This is very important. So you may use or you must use a sufficient number of implants to retain your overdenture here. The resilient attachment allowed some controlled vertical movements. They induce less torque on implants because it is resilient. It allows denture movement. So all the forces shared between the alveolar ridge and the dental implant. However, they are more complex in design and the fabrication than the rigid attachment. Attachment can be also categorized or classified into 2 categories: precision attachment and the semi-precision attachment. Precision attachments, it is a ready-made attachment. Their components are machined in a special alloys under special and precise tolerance. It has a less wear, standard parts, and easier to repair. The semi-precision attachment is fabricated by direct casting of plastic, wax, or refractory patterns, subject to variable of fabrication and economy. It is very easy and very cheap also to be made, the semi-precision attachment for your patients. You can't need to buy any parts from the attachment company. Some parts of some types of the semi-precision attachment, you can buy only a plastic pattern and make a casting for it. Once you make a casting for an attachment part, it will be called a semi-precision attachment, because the casting procedures, the casting procedures the lab make, this casting procedures may the dimensional instability may be achieved in this type of attachment, so it will be less accurate than the precision attachment. Here we are talking about the first part of the attachment. Here, the stud attachment consisted of a female part which is fractionally retained over the male stud and incorporated into the resin denture base, either by the means of a transfer coping system or a functional pickup. It classified according to the function into resilient and non-resilient attachments. The resilient type permits some tissue-ward vertical and rotational movement, thus protecting the underlying implants against the overload. The non-resilient type doesn't permit any movement of the overdenture during the function. So it will be non-resilient here, or rigid. Indicated when the interocclusal space was limited and used in cases with V-shaped arches where the straight connection between the implants can affect the tongue space. Here we are talking about the O-ring attachment. It is a type of ball and socket attachment. It consists of a titanium male unit and an easily replaceable rubber ring, as we see here. This is a rubber ring here around the ball neck. The rubber ring here with the female housing is considered as the female unit that is retained in a metal retainer ring, what we call a metal housing or a metal retainer. This is a metal retainer ring here, and this is the metal housing that housing all this attachment assembly. It transfers the amount of stress to the abutment. We can have this type of attachment in a single piece with the implant. The ball and the implant is a single piece here, and we can have it as a two-piece form. The ball attachment here is the abutment, and we can screw it inside the implant fixture, inside the patient mouth. It transfers the amount of stress to the abutments and provide an excellent shock resorbing effect during the function. So it will be a very resilient attachment, and this type of attachment is the most commonly used with the most of companies or the most of implant companies that we deal with. When the O-ring attachment were properly placed parallel to each other, the retention was adequate for a longer time. The retentive capacity of the O-ring was affected by implant inclination also. This type of attachment can give or can withstand the different angulation of the implant up to 15 degrees for each implant, and but it preferred to be parallel to each other to decrease the wear of this O-ring or the female cap if it is used with the ball attachment. Here we are talking about the ball and socket. Consists of a metal ball, male portion, which is screwed into the fixture, where the female part is incorporated into the fitting surface of the denture. The female part may be one of the following types: the O-ring, in which the retentive elements is a rubber ring. It's better to have parallel implants, as we said before. Otherwise, the rubber ring will wear within a few weeks. A metal part as Dalbo system. This permits less resistance. The Dalbo system, we have the metal part is the resilient part. It will squeeze to allow the female metal cap to catch it and give a mechanical retention. The retentive forces are almost twice those obtained with the O-ring system. A spherical metal ball in which the female part is a plastic cap. Also, this is the third option. This type of attachment is low cost, easy of handling, and the minimal shear side time needed for loading inside the patient mouth. Here, this is the type of what we talk about, the ball and socket type. Here we have a normal ball size. This is a micro ball. The normal ball here diameter is about 2.5 millimeter. The micro ball here is about 1.8 millimeter. This is rain attachment, I think. The manufacturer gives you many colors of caps. This indicate a different amount of retention and a different amount of female cap resiliency. This is the directional rings that you can use. This is 7 degrees. This is 14 degrees. You can use this directional rings to make, as you see here, to make the female cap parallel to each other to decrease the wear of the female cap. You can rotate this directional ring until the female caps parallel to each other, as we see here. Also, some types of ball, as you see here, called the spheroflex types. This ball can also rotate to give another about 10 degrees of angulation in order to compensate for this implant angulation, as you see here. Here we can maintain the female housing or the female caps from wear and live for a long time inside the denture. So the ball and socket decrease the forces from all directions on the implant. It will be easy to construct, use, and maintain. Low cost, and it's the most simplest type of attachment we can use. Excellent controllable retention. We can use caps or O-rings as a female housing or a female part with it. Now we are talking about the locator attachment, an attachment system with self-aligning feature and has dual retention, inner and outer. So every part of this attachment will be a male and a female for the other type. So despite it has a short prosthetic profile, but it has a very strong retention. Come in different colors, white, pink, or blue, and each has different retentive value. Extended range attachment, which can be used to correct implant angulation up to 20 degrees. They are offered in green, which has a standard retention, and red, which has an extra light retention. The reduced height of this attachment is advantageous for cases with a limited interocclusal space. Retrofitting of an existing old denture, if the patient has an old complete denture and you make an two single piece mini implants and will immediately load these implants with an overdenture, you can use this type because it is very resilient and decrease the forces falling onto the implants up to 90%. Affect the load transfer to the implant also. This is the locator, as you see here. The male part here have this is the male part and have also a female part inside it for this male part of the cap here, of the nylon cap here. And we have also a female part in each type. This is the male and the female inside it, and the housing here have a cap with a male part and a female part also for the abutment here. As you see, the height of this type of locator will be only 2 millimeters. This is a very short height. You can use in limited inter-arch space cases. And also give a strong retention, a very strong retention, as we said before. This is the equator type. We make this slide to compare between the locator and the equator. The locator, the difference between them is the locator have a double retention value, as we said before. Every part have a male and a female, but the equator is like a ball. You struck it with a hammer and make it flat. It is a ball with a flat configuration, as you see here. And also have a very short prosthetic profile, also only 2.1 millimeter and a diameter of 4.4 millimeter. We have also different colors, as you see here. Every color here with a different degree of resiliency. You can give your patient the amount of retention you need according to the color used here. Here, this is a modification of the locator attachment called the ERA attachment. The abutments are available into two types: straight one-piece abutment type here, and the two pieces angulated. As you see here, you can unscrew the attachment from the abutment. Two pieces angulated abutment types. The manufacturer gave us a different angulation to compensate for the implant angulation here, up to 30 degree, 5 degrees, 11 and 17 angles. Each ERA retentive system is available into 4 color codes: white, orange, blue, and gray, as you see here, that provide different degrees of retention from light to heavy retention. It is indicated when the resiliency is required, as it provides vertical resiliency and universal stress relief action. In this slide, we have a cross-section, a longitudinal section, for the different type of attachments. This is the O-ring attachment here. This is a rubber O-ring that engages the mechanical undercut from the ball. We have here a vertical space to give up and down movement, and this O-ring gives us a rotational movement and the hinge movement. So it gives 3 types of movement. So it's a very resilient attachment to be used over your implant. This is the cap type, the ball and socket. We used here a plastic cap. We can, according to the resiliency, we can give different types of retention for it. This is the equator type. It resembles the ball, but it's a flat top and a less prosthetic height here. This is the locator. As we see, every part have a male and a female. This is the male part of the abutment, and this is the female part here. This is the male part of the plastic cap, and this is the male part here. Engage into the female part here by friction, so gives a physical friction here. And this is the female part, that the male part of the attachment of the abutment, engage it here. So it has a very strong mechanical and physical frictional retention. This is the ERA attachment, the modified part, the modified type of the locator attachment. Now we are talking about the magnets. All of us know the magnet concept or the magnetic concept. The magnet is usually cylindrical or dome-shaped, as you see here, attached to the fitting surface of the acrylic resin base of the overdenture. The magnetic keeper casted here, casted to the metal coping screwed over the implant fixture. The magnet made from boron alloy or cobalt samarium alloy. The keeper part here is ferromagnetic, which is screwed into the implant. This is the keeper, and this is the magnet that will be added to the fitting surface of the denture. The retention force of the magnet decreased with time. This is a disadvantage. And the retention of ball and the bar or the bar attachment is more than this type of magnetic attachment. But this attachment is considered the most resilient attachment ever you can be used. So if you want to make an immediate loading with a questionable case, you can use this type of attachment without being afraid of implant failure. The immediate loading of magnetic attachment is also an option, as we said before. Then we are talking about the bar attachment here. This is a bar connecting the abutments of the implants. We call it a splinting type of attachment, and the claps inside the denture base will be used to have a mechanical retention from this bar. A bar attachment is in the form of a bar contoured to run parallel and overlies the residual ridge here. Overlies the residual ridge and must follow also the shape of the ridge, connecting the implants together. This bar gives us support, retention, and stability for the overdenture and also splinting the implants. This will make a good distribution of force that of the masticatory force over all implants in the arch. We have two types of bar attachments. The first part is called bar unit. Rigid fixation, where there is no movement between the bar and the overlying sleeve. To use a bar unit, the bar unit don't allow any movement. It's called a rigid bar or a non-resilient bar. So we must use a sufficient number of implants because the implants will receive all the masticatory load falling on the overdenture. So we must distribute these forces over a sufficient number of implants that will be strategically distributed also onto the arch can withstand this masticatory load. But here in bar joint, it permits rotational movement between the sleeve and the bar, utilizing some of the residual ridge for support here. Here's this type we call the bar is having a pear-shaped cross-section or rounded cross-section here, and the sleeve can move around it as a hinge movement. This will be called a hinge movement, like the hinge of the door. But here, if we have a rectangular cross-section here, this rectangular cross-section can't give us movement, so it will be considered as a rigid bar. The bar shouldn't cause food entrapment between the bar and the mucosa, and should not cause food entrapment also around the implant here, not to cause peri-implantitis and the sequelae of implant failure. Should not cause also blanching of the tissues, must not exerting any pressure on the alveolar mucosa under it. Should not encourage also the tissue proliferation or tissue hyperplasia. Here we can also give a vertical movement for the bar here by making a vertical spacer like this when we making the functional pickup, as we said in the last lecture. Here the vertical spacer here is put between the male bar here and the metallic sleeve to be removed later, and we will have a vertical space here that allow up and down movement. I don't have if it is any problem with the lecture.
No, doctor, everything is working fine.
Okay, Dr. Sar. Here we have many commercial types like Dolder bar here. This is a single sleeve bar. We have a multiple sleeve system also. We can use the bar in many sections, as we see here. We can make a cantilever extension up to 5 or 7 millimeters and have another clap here, as you see. to will get use of more area of support and retention for the denture. Okay, sorry for being more fast. We have a long lecture in a very short time. Now we are talking about the telescopic type. We said that we use it in implant supported overdenture. We use here a telescopic crown, as you see here, or we may call it a double crown or a crown and sleeve coping. A primary crown, this crown is the abutment that is screwed into the implant, and the secondary crown or the secondary sleeve or secondary coping will be incorporated into the framework of the denture above, as you see. It provides excellent retention resulting from frictional effect between the crown and the sleeve, provide better force distribution due to the circumferential relation of the outer crown to the abutment, which makes the axial transfer of occlusal load here that produce a less rotational torque onto the abutment by improving crown root ratio, so preserving the tooth and the alveolar bone. It can be used in tooth supported overdenture, and it can be used also onto the implant supported overdenture. It can be classified into parallel sided crowns, as you see here. The other type, tapered conical shaped crowns, and the third type, crowns with additional attachment. So the attachment here may be fractional only, fractional physical retention, and there may be fractional mechanical retention can be incorporated in this type of attachment. So we must know the movement allowed by resilient attachment, and this will be beneficial, very beneficial in attachment selection. It may give only a vertical movement up and down, hinge movement. This is accessed by most posterior attachment. Rotate about this fulcrum line. Rotational movements access around the crest of the ridge. Translation or fishtail movement, anterior posterior movement or bacolingual movement, and the last type is a combination between 2 or 3 types of the previous type we mentioned. Okay, types of attachment based on resiliency can be classified into rigid non-resilient attachment. Here, no movement between the denture and the implant. This is very rigid connection. Implant receive 100% of shearing forces. When sufficient number of implant placed, we can use this type. It can't be used with a few number of implants. An example of this type is screw-retained hybrid prosthesis as all-on-4 prosthesis and totally implant-supported rigid bar complete overdenture. Second type is vertical resilient attachment. It provides from 5 to 10% load relief to the implant. Prosthesis here moves up and down with no lateral or rotatory movements, only up and down movement. Hinge resilient attachment resist lateral tipping and rotational forces, provide 30% to 35% load relief to the implant. Example for it, Hadar bar or any form of the rounded bar that can give the hinge movement. Combination resilient attachment allow restricted vertical and hinge movements. This type increase tissue support of the prosthesis and transmit any force direction, vertical and perpendicular to the ridge crest. It provides 45 and 55% load relief to the implant. Example for it, the Dolder bar with the vertical spacer. We see it before in a photo. The next resilient type is rotary resilient attachment. It provides vertical, hinge, and rotational movements, 3 types of movement. As the O-ring attachment, as we mentioned before, movement determined by direction, location, and the magnitude of forces. provide 75 to 85% load relief to the implant. Example for it, the stud attachment or the O-ring attachment, as we mentioned before. Number 6 here, the universal resilient attachment. It provides vertical hinge translation and rotation movement. It gives all types of movement we can gain. It gives all movements except that away from the ridge. It prevents the denture to be dislodged away from the ridge. This is the only movement that this attachment prevent from happening. Provide 95%, as you see, load relief to the implant, so it can be used in immediate loading, as we said before. An example for it is the magnetic attachment. So the most important thing is to know now is the attachment selection criteria, how you select your attachment for your case. First option here is bone quality and the quantity. When we have a good bone quality and the quantity, you can use the ridge for sharing the load. So here you can use a resilient attachment in order to make the ridge sharing the load with the dental implant. The arch form also is very important option. If you have a V-shaped arch, so you have a stability problem. So you have an abused ridge form that can't be beneficial for the stability. So you may use the bar attachment to give you more stability. Third option here is the inter-arch space. It is a very important option, and you can analyze that by making a mounted study cast for your case and measure the inter-arch space first before you select or order it from the company. You must analyze the inter-arch space first, then you are going to select the most suitable type of attachment. If you have 20 millimeter inter-arch space, you can use a bar or telescope. If you have 10 or 9 millimeter inter-arch space, you can use a ball and socket type. If you have only 5 millimeters inter-arch space, you can use locator or equator type. Okay. Most important option also is financial ability. If the patient can afford the precision attachment, it will be more have higher price than the semi-precision attachment. If the patient are poor and can't afford these fees, you can use the semi-precision attachment. Number 5 here, patient expectations and need is also important. The dentist and the technician skills is also important. Like the type we said before, the telescopic crowns or the telescopic attachment. You must have some skills, and your laboratory technicians have very high skills in order to make the path of insertion and the axial walls of these crowns parallel to each other, and they may have also an idea about the digital workflow in order to make this type of attachment. Opposing dentition is also very important. If you have the opposing dentition is natural teeth or zirconia crowns or porcelain crowns, you will have here a high magnitude of occlusal forces, so you may use a very resilient attachment here to counteract or giving a cushion for the high magnitude of forces that are falling from the opposing occlusion. Implant number here is also important. If we have a good implant number in your arch, you can use a rigid attachment and gain the most powerful retention from it, and also support and stability. If you have a less number of implants, you must use a resilient attachment to decrease the forces falling onto these implants. Implant length and the diameter is also important, and the diameter is more important than the length, because this will increase the functional surface area and the area of osseointegration, and this makes the implant tolerate more forces and tolerate more rigid attachment. Also, implant distribution in the arch is the strategic distribution we are talking about. is very important in implant selection. The inter-implant distance, what we call EP spread concept. This is the line if you have 4 implants that are equally distributed into the arch, 1 implant in each quadrant. So the line passing between the center of the anterior implant and the line passing between the distal surface of the posterior implant, this is what we call the EP spread. You can use a cantilever extension up to 2x or double the distance between these lines. Loading protocol is also important if you want to make an immediate loading. So use the most resilient attachment type in order to decrease the failure rate for your implant. Degree of osseointegration or the bone implant interface or implant bone interface is very important. Soft tissue condition is also very important. If you have an abused ridge or abused soft tissue condition, so it's preferred to use a bar attachment in order to make your support away from this abused ridge. So we can summarize the attachment selection criteria into these points. Advanced resorption of the alveolar ridge if you have a case of advanced ridge resorption, so use bar or telescopic attachment. If you have a minimal resorption of alveolar ridge, so use ball, magnetic, locator, or equator, whatever the type you need. Patient with narrow ridge, use ball here better than a bar because the bar here interfere with the tongue space and interfere with the tongue movement. Rigid telescopic coping gives us a very good support, retention, and stability, but it increases the forces to the implant and then increase the implant fatigue and the fracture of implant or the implant components like the abutments or the implant screw. Magnets provide the least retention of all types and lost retention power with time. This is the great disadvantage of the magnet type. The last thing we will talk about is the biomechanics in attachment selection. The bar connecting the implant should be parallel to the hinge axis, should follow the crest of the ridge. This is also to not interfere with the tongue space and not and to allow the hinge movement we talked about before. The distal extension bar increase the level of stability, but splinting action of the bar disappear. Then increase non-axial load on the implant. Ball attachment may be better in load distribution than the bars. This is some researches that is made between a comparison here between the bar attachment and the ball attachment. Fixed implant prosthesis equal rigid bar implant supported overdenture. So you must have a sufficient number of implants that is strategically distributed onto the arch. If we have a 4, 2 in canine area and 2 on 5 or 6 area, this is the best distribution for minimal number of implants. Last thing here, we will talk about impression techniques that will be used for overdenture. Here, the impressions techniques for overdenture will be classified into impression techniques for implant-supported overdenture and the impression techniques for implant-retained overdenture. Implant-supported overdenture, we will have a single-phase impression or all-in-one impression technique. As we know here, the splanted and the non-splanted impression techniques of open tray implant level or abutment level, we can use both. But I prefer here the splanted types because it has, if you want to splant your implants in your prosthesis, so please splant splant your impression, splant your impression posts or splant your transfer copings so you can have an accurate records. The implant retained overdenture is also classified into dual phase and the pickup. The dual phase is a selective pressure impression technique, and we will have the functional pickup technique that will be talked about in the next video. The dual phase here we may use a single tray and double material here, and we may use double tray and double material. Let's see this video to see how we can make the relationship between the male and the female portion.
Confirm that the prosthetic platform is free of any bone or soft tissue debris.
We remove the healing cap here from the dental implant.
Place the ball abutment onto the implant body and hand tighten.
Then screw
Place each ball abutment
the ball
after
attachment.
removing the healing abutment to prevent the soft tissue from collapsing over the implant.
And this is very fast to prevent the collapses of soft
Each ball
tissue
abutment to
or
30 Newton centimeters.
saliva, or
Using
entering
both
to prevent entering
and
saliva or blood
calibrated
into the implant hex, and then fasten it with a torque
Lock out
wrench.
the hex hole on the top of the ball abutments.
Then close here
Syringe medium
the top
or
of
heavy
the ball
body
abutment
material
here.
around and over the abutment.
Inject light rubber base here around the implant, then medium rubber
Load
base.
the impression tray with material and
Here
make the
we use
impression.
a single tray with a double material.
Once the impression material has set, remove the tray.
Then we remove the tray from the patient mouth, as you
Insert
said,
ball
as you see
abutment
here.
analogs into the
Then
impression.
abutment and the implant analogs inserted into
Send
the
the
impression
impression to the
and
lab.
send it to the lab in order making
Verify that
your
the analogs
prosthesis.
are properly seated in the impression.
Then the lab here add a soft tissue replica. Then
Fabricate a working model
pour
using
the cast with the
high
stone.
hardness guy stone. Articulate the model according to normal laboratory.
Here the lab have a positive replica of your patient mouth that can make the denture over it. Next type here,
The healing abutment and confirm that the prosthetic
we see here
platform is free
the
of
functional
bone
pickup
or
technique.
soft tissue debris.
As before,
Select
we
the
remove
ball
the healing
abutment
cap
based on the prosthetic platform and the tissue height.
and
Measure the tissue height
measure
from the top
the height of the
implant
soft
to the
tissue
top
here
of
by
the
using a
implant at
periodontal
its
probe.
highest point.
To
Choose the
select
abutment
an
cup
abutment height,
equal
your
to
abutment
or
height
slightly
must be
taller than the tissue.
equigingival or
Place the
above
ball abutment
the gingival
onto the
height
implant
by
body
about 1
using the
millimeter.
hex driver and hand tighten. Place each ball abutment immediately after removing the healing abutment to prevent soft tissue from collapsing over the implant.
We add another. Then we add
Place a blockout spacer and a housing cap with a black lab processing insert onto each ball abutment.
A spacer for protection of the mucosa, from the self-cure acrylic. We don't want to cause any thermal or chemical burn for our patients. Then we ensure that the denture is passively inserted.
Ensure that there is no
Make a
contact
hole
between the denture and the housing caps.
for the
Make
excess
removable vent holes
self-cure
to allow the
acrylic.
release of excess acrylic. Place light cure or self-curing permanent
Then
acrylic
we add
around and
self-cure
over the ball
over
abutment
the caps and
housing cap.
inside the
Place
denture,
a small amount of acrylic into the recesses
self-cure
in the denture.
acrylic, and
Insert
make
the
your
denture
patient
and guide the
to
patient
bite
into a
eccentric
Maintain the denture
and
in the
wait
passive
until
position without compressing the soft tissue. while the
the
acrylic sets.
self-cure set.
After the acrylic has cured,
Then remove your denture and remove the
fill in
black
the voids
insert
and remove excess acrylic around the housing cap
from
and
inside the
removable
cap
vent holes.
and remove the excess self-cure acrylic.
Remove the black lab inserts from the housing cap using a rotary instrument operated at a low speed.
Then
to avoid
add
damaging the housing cap.
your
Choose
cap
the desired retention
with
strength.
the desired
Insert
retention
the
you
retention
want for
cap
your
into
patient.
the housing using the ball abutment insert tool. Seat the overdenture onto the ball abutment.
Then seat
and
the
modify
denture inside the
inclusion
patient
as
mouth.
necessary.
The denture is now delivered.
Verify the patient's
inside your
ability
patient
to
mouth.
remove and seat the denture properly. If the denture has too much or too little retention, select.
If you see that your patient here has too much retention or or weak retention, you can change the plastic cap. You can change it by using another cap of a with a desired retention. Here we see a form of the locator.
Remove the healing abutment and confirm that the
We
prosthetic
remove
flap
the
is
healing
free of
abutment
any
first.
bone or soft tissue debris. Remove the hand driver from the locator core tool.
By using the hand driver here, we insert the locator and rotate it by hand inside the patient mouse.
Place the locator abutment onto the implant body and hand tighten.
Tighten by hand first, then by ratchet.
Healing abutment to prevent soft tissue from collapsing over the implant. Tighten each locator abutment to 30 Newton centimeters using a calibrated torque wrench and a locator square drive tool. Snap the impression coping.
This is the impression coping that is used for the locator attachment.
Syringe medium or heavy body
We
material around
inject a light rubber base around it, then or a medium, then a tray loaded with medium rubber base inserted into the patient mouse.
Material and make the impression. Once the impression material has set, remove the tray and the copings will be picked up.
Then we removed the tray and inserted the abutment analog with the implant analog into the transfer coping.
Attach the locator analog to the coping in the impression. Send the impression to the lab.
Then we send that to the lab in order to pour the cast and making your procedures.
Analog are properly assembled. Syringe soft tissue replica material around the analog.
This is the soft tissue replica.
Fabricate a working model using minimal expansion, high hardness die stone. Articulate the model.
Okay, we can use also the functional pickup technique with the locator, like the ball attachment.
The prosthetic platform is free of any bone or soft tissue debris. Select the locator abutment based on the prosthetic platform and the tissue height.
We measure the height of the soft tissue to select the abutment height.
At its highest point. Choose the abutment height that is equal to or slightly taller than the tissue. Place the locator abutment onto the implant body using the locator hand driver with a locator abutment holder and hand tighten. Place each locator abutment immediately after removing the healing abutment to prevent soft tissue from collapsing over the implant. Tighten each locator abutment to 30 Newton centimeters using a locator square drive tool and a calibrated torque wrench. Place a white blockout spacer and a housing cap with a black lab processing insert.
Add the black insert inside the metal housing and
place a transfer mark on the top of
the housing with indelible marker in order to know if there is any interference with the denture base, as we made before. Then make a hole into the lingual flange for the excess self-cure acrylic to escape from.
Place light cure or self-curing permanent acrylic around and over the locator abutment housing caps. Place a small amount of acrylic into the recess in the denture. Insert the denture and guide the patient into occlusion. Maintain the denture in a passive position without compressing the soft tissue while the acrylic sets. After the acrylic has cured, remove the denture.
This is a very very easy technique and a very professional technique for making the relationship between the male and the female portion. And here we using the patient own biting force to make this relationship during the function and during the biting of the patient. Here we insert the cap of the locator inside the denture, inside the metal housing, and then insert the denture inside your patient mouse. You can now deliver your denture.
Verify the patient's ability to remove and seat the denture properly. If the denture has too much or too little retention.
Okay, this is the old or the conventional impression techniques, what is in the future, the optical impression, by you can make impression. You can use as an intraoral scanner for scanning your abutments, for scanning your abutments, as you see here. Prepare the scan with the spray or without spray. You can make a digital impression, as you see here, and this is as a replacement now for the old impression techniques we mentioned before. So thank you for listening for my lecture, and thank you, Dr. Sarah, for this opportunity to meet my friends all over the world.